Now let's dive into an example of the normal curve with actual data so we can see how this all works. So just a reminder, we're going to use the standard normal approximation. So this involves basically estimating percentages of values in a given interval by converting the endpoints to z-scores and then using the table to find the area under the standard normal curve. And again, it's always important to keep in mind that this can only be used when the data is close to following the normal curve. Otherwise, we're going to have inaccurate percentages. So I like to think of doing these problems kind of in 3 steps. The first step is to go ahead and convert your values to standard units or z-scores. And the formula for z-scores, I like to think of it in words. Z is equal to value minus average divided by standard deviation. But you can also think of this in symbols. A lot of times we represent the value with x, the average or the mean with mu, or x bar, either works, and then the standard deviation with sigma. So after you've converted to z-scores, you definitely want to draw a picture of the area you want so you know which area to look up on the normal table. And then lastly, you want to relate your picture to the area in the table and find the answer to the question. So puzzle number 1 says a list of weights follows the normal curve. Good, that's what we like to hear, and has an average of 150 pounds and an SD of 20 pounds. The first question asks us what percentage of people weigh less than 115 pounds. So before we learned about the standard normal curve, I would have to go ahead and draw my histogram, calculate the area of the blocks that are less than 115 pounds, or go to Python and kind of try and estimate it from my histogram. But now that we know about the standard normal curve, let's go ahead and use this technique to estimate what the answer to this question is. So step 1 is to convert to standard units or z-scores. So I only have one value here. I want to know what percentage of people weigh less than 115 pounds. And if I tried to mark 115 pounds on the normal curve right away, if I'm using the standard normal curve, 115, where does that go? That seems crazy because 115 is in pounds, which is really big, and the normal curve is in z-scores. So 115 doesn't even make sense to put on this standard normal curve. So that's why my first step is to go ahead and convert that to a z-score so I can figure out how many standard deviations is 115 either above or below average. So my z-score formula is value, which is 115, minus the average, which the problem gave us to be 150, divided by the standard deviation, which is 20. And wait, if you can do that calculation for me, we should get, before I even know the answer, I know that I should get a negative z-score because 115 is a below average value.
So I get a z-score of negative 1.75.
Negative 1.75. So what this is saying is that 115 pounds is the same as a z-score of negative 1.75. And 115 has the units of pounds. Negative 1.75 is in standard units. It doesn't have any units. So now I can mark negative 1.75 on my normal curve right here. Here is negative 1.75. And if I wanted to think about this in terms of pounds, I could do that too. I personally like being in z-scores just because I think it makes it clean to work with the normal curve. But if I wanted to, I might as well do this. This corresponds to 115 pounds. And if I wanted to think about the average right at 0, this is 150 pounds. So the placement of 115 pounds makes sense. That is a negative z-score. And again, just to super emphasize what that means, this means that if you're 115 pounds, you are 1.75 standard deviations below the average. So I did step 1, which was to convert to z-scores. Step 2 is to draw a picture of the area I want, or to shade. And we want to know what percent of people weigh less than 115 pounds. So I'm going to shade everything to the left. And then my very last step is to go ahead and use the normal table to calculate the area to the left of negative 1.75. And if I look at my normal table that we have seen, it doesn't have negative numbers. So I would actually have to look at 1.75 on the normal table and then figure out how that percentile is going to help me answer this question. So if I look up positive 1.75, that's going to give me the area to the left of 1.75, which is, wait, do you have the normal table?
Yeah, I just brought it up and I'm looking at the 1.7 row and going down the 0.05 and I get 9599.
0.9599. And so I know that the area to the left of 1.75 is 0.9599. And I can easily figure out this area to the right by doing 1 minus 0.9599.
Which is 0.0401.
Which is 0.0401. And so that gives me the right-hand tail. The area I want is the left-hand tail. But because the normal curve is nice and symmetric, the two tails are always going to be equal. So I know that my answer is going to be just 0.0401. So I can say that we found the area to the left of 1.75 because our normal table only gives us the positive z-scores. That was 0.9599. And then the area to the right of 1.75 is just 1 minus that, 1 minus 0.9599, and I got 0.0401. And this area to the right is just also known as the right tail. So our area that we want is the left tail. And we know that the left tail and the right tail have to be equal because the normal curve is symmetric. So again, my answer is going to be 0.0401. So let's just go back really quick and think about what this means. So this means that 0.0401 or about 4% of people weigh less than 115 pounds. And that makes sense if the average is 150 and the SD is about 20. So let's go to part B. It says, what percentage of people weigh between 115 pounds and 160 pounds? So I'm going to do the same kind of steps that we did before, which is convert these two values to z-scores. And we know 115 pounds, the z-score is negative 1.75. So for 160, I can use my classic z-score formula, which is value 160 minus the average, which was given as 150, divided by the SD, which is 20. And that gives me 0.5.
Yeah, 10 over 20.
10 over 20. So I did step 1, I converted to z-scores, and now let's do step 2, which is drawing my picture. So we have 0 right in the middle, we have negative 1.75 about right here, and this represents 115 pounds, and then we have 0.5 about right here, which represents 160 pounds. And we want to know what percent of people weigh between those values. So again, we know that if you weigh 115 pounds, you're 1.75 standard deviations below the average. If you weigh 160 pounds in this data set, you are 0.5 standard deviations or a half a standard deviation above average. So when calculating this area, there's a bunch of different ways to do it. It's kind of like a puzzle. You can decide whatever way makes the most sense to you. To me, I know that the area to the left of negative 1.75, we already found that. We know that that is 0.0401. And I can find the area to the left of 0.5 and then just subtract them. So that's how I would do this problem, but again, there's a bunch of different ways you can do it. So the area to the left of 0.5, I would just go to my normal table, look up z equals 0.5, and I end up getting...
I looked at 0.5 and then plus 0 is 0.6915.
0.6915. So I know that the area to the left of 0.5 is 0.6915. The area to the left of 1.75, negative 1.75 is 0.0401. So I can just subtract those to get my total area. 0.6915 minus 0.0401 is what?
0.6514.
0.6514, or about 65% of people weigh between 115 and 160 pounds. So we can calculate any percentage that we're curious about for this data. The last question asks us what percent of people weigh above 160 pounds. Well, this should be a quick one because we know 160 pounds is a z-score of 0.5. So I can go ahead and mark that on my standard normal curve. Here is 0.5. And I want to know what percent of people are above that weight. So I'm going to shade everything to the right. So I did step 2, or I did step 1 in the previous problem. And then lastly, I want to know for my area, what's the area to the right of 0.5? And Wade, you told me the area to the left of 0.5, right?
Yeah, the area to the left of 0.5, that was way back on the table, and it was 0.6915.
0.6915. So the whole normal curve is 100%. I can just take, to get my final area, 1 minus 0.6915.
Which I get 0.3805.
0.3805.
Sorry, 3085.
Oh,
sorry. I screwed up 2 digits.
No worries, 3085. So what this is saying is if you're 160 pounds, you're slightly above average. You're 0.5 standard deviations above average to be exact. And about 31% of people in the data set weigh more than you. So hopefully this helps with using the normal curve to answer questions about our data. And again, you can convert any units to standard units. So hopefully we'll see a bunch more examples where you can keep nerding out with the standard normal curve.